Okay, so this is a talk of like I worked as an architect for like a couple of years before, and I wasn't doing like any engineering work. And when I tried like to convey a message like what is it about, like I realized like most engineers have like very skewed perception of architecture. And by like talking like with Kevin, for example, like it came to an idea like how to like trying to like bridge this gap between like how architects thinks and how engineers think, and why architects are usually like annoying for engineers, and why is there a good reason for this, and like why it's like not there are no ill intent in that. Yeah. And I need to give me a second.
Yeah. Also known as you're doing it wrong, and this is how to do it right.
It's mostly you're not like usually given an information like what architect is doing. So like, you know, like maybe it's right, maybe it's wrong, but like communications is usually skewed. Like this is the end result, and you don't, like engineers do not have like enough information to evaluate. Is it right? Is it wrong? Like just something, but it's very hard to do it because like in engineering everything is precise, and I'll try to demystify this. Yeah. Okay, so typical engineering experience. So it will be problem, solution, like you ship result, all great. Why would you need an architect? So local reasoning work. So you see the problem, you see like existing code, you solve, and you can ship it like it's done. Like what else to think about? Like you immediately have feedback. Like you run your code and it's either work or not, and like you might be using a unit test, and it gives you like even like broader feedback. Like it works actually in many cases, not just like input that you gave it immediately. It gives you like nice feeling when it's worked, like yeah, I did it. Yeah. So nothing wrong with this mental model, but as I started, it's actually very local. So it works for a solution. You're given a problem, you're solving it. In this aspect, it works, but it doesn't step out, and the outer world, it does exist. So like how enterprise architects usually look to an engineer. So like you given like constraints, like diagrams, and like you made my life hard for no apparent reason. Like you just like make it think like certain way. You have to use, I don't know, like MySQL. Like why like Mongo will fit here better. Why do I have to do it? Why do I have to prepare like release documents? I know how it works. Who's gonna use them? Like usually engineers like not being told like who are they like for? Is that like is it a regulator? Is it for end users? Is there some compliance process? Like no one, you just like have to do, and it breaks the like previous model. Like you don't have result. You do work without any gratification. You don't know like is it work? Is it correct? It's just like you do like some monkey work. Like it's at least it looks like it. Yeah. So it just like adds friction. Like you cannot do this. There's a certain process. The obvious cost. Now it makes it harder because previously you solve any problem, you get a solution. Now you have to do something extra. So cost is here. It's your time. It's like company money. No outcome. So that's why most engineers see architecture as just like red tape. Like we don't need it. We can figure out ourselves, and you can do in a like local scale. So let's look at like examples. Dropbox, Python. So like they build Dropbox. It's a big system, 4 million lines of code. At some point, they came to a like state where like we cannot ship any new feature. What they did, they introduced MyPy. So MyPy introduced types like static type in a dynamically typed language. So it actually solved the problem. They were able like to continue. They went from like 4 million lines to 5 million lines of code, while before they were stuck. It wasn't about like making it right. It's just like making it like survive. So they like try like to crawl it out, and they were like big enough and successful enough financially that they can afford it. So not really like an architectural decision, just like salvage. So now Facebook, similar situation. They delivering everything in PHP. it's working, it's making money. At some point, they got stuck, and it wasn't just we cannot ship new features. Performance trap became unescapable. We cannot make it performance enough. We cannot scale horizontally, and there are no machines VM itself not letting you scale vertically. So they introduced Hack. It's the same story. We introduced static types into a dynamic language, and they went further. They introduced HHVM. It's a VM that relieved some constraints of PHP, because when PHP was designed, people had in mind few pages. You run it and it just works. You're not trying to build an enterprise on the shoulders of PHP. It's supposed to be quick and easy and maybe dirty. It just works. So after careful deliberation, they use certain language for Hack and HHVM. So most knowledge they had with PHP and actually C++. PHP, we have loads of engineers in Facebook. We have a lot of inherent enterprise knowledge. C++. Great performance, and what did they choose for Hack and HHVM? A camel. And it brings us to an interesting topic. It means they were able to recognize what is the problem, and they did a proper analysis and realized, okay, we need something verifiable. We need static types, and we looked at the actually all available solution. And despite a camel is barely known, said, okay, for this project, to pull us out of this dynamic hole, we need something verifiable, statically typable with sound type system. So now Facebook is major user of a camel, just because they decide, okay, we cannot continue patching the way Dropbox is doing. We already have a solution. We'll just use it. We're not gonna re-implement the wheel. But it gives us into insight. So if they thought about it earlier, say our velocity drops, we're shipping features slower and slower. They were unable to recognize this trend. They could have just rewritten part of the code in a camel instead of introducing Hack as a fix for PHP, and it will be significantly cheaper because it's already exists. You don't no one need Hack today. People who use PHP need PHP. People who need static types, they use something else, and even Facebook themselves recognize that at least a camel exists. But again, big corporations have enough money to dig themselves out of the hole and recognize what is the tool for the job. Yeah. So what is the actual problem here? So it's not about choosing PHP or a camel or Elixir or Lang. It's how you make decision and how you make sure that it's a scientific decision. So definition of scientific, when you make a theory, it have to be falsifiable. So you should whenever you make a decision, I will go with PHP, I will go with Mongo, I will go with Erlang, it will be cloud or on-prem. It should be a certain way to check is it still true? Is it should I continue with the cloud today, or should I move to on-prem? Should I continue with PHP, or should I move somewhere else? And this is usually missing part, and it's missing often in enterprise, but very commonly from engineering standpoint, because when you have a solution, it's very local problem. You're probably not gonna get to a point where you need to redesign it, otherwise it will cost you arm and leg to redo it. You don't think it's oh, I would need to reinvent Hack and type system for this project to continue. But architects have to take it into account. So we have multiple solutions. We have a lot of different problems. Are we going to run into 4 million lines of dynamically typed lines of code problem in the future? And at which point we actually have to introduce static typing? Because using, I don't know, ADA, perfect verification, language that's running aircrafts, using it for startup, it's stupidest idea. You'll spend first a year defining all your theorems, and you'll never ship anything. You'll run out of money before it become practical. But then if you do something you aim is aerospace area, you can start with PHP, but you should have this decision point where you say, okay, we're successful enough we get into a point where we need to prove it to regulators. We need to make sure that it's running in all situations, and we need some way to tell what is the properties of what we did, and we need to switch somewhere. But usually it's not defined. It's a job of an architect to say this is decision for today, and this is a moment when this decision no longer stands, and we need to reevaluate it. And but to decision to be reevaluated, it needs to be implemented, and that's why the process. That's why the red tape. So architects have to know what engineers are doing, so I can actually make a decision. Because if you think we can run PHP until we have 20 people in a company, if they're no control, if gave this as a decision and never came back, and they're no engineers actually looking at and going every day and counting heads. In my team there are 5, in this team there are 6, and other teams there are 12. You will never come to a point where say, oh, we actually have to reevaluate our decision to use a dynamically typed language, for example. So that's why architect needs this constraint, so they know, okay, when you're hiring, you have to report back to me, to architect, to HR, to whatever, because this is the key decision point, to change what are we doing up till this point. For engineer on HR, it's look like red tape. It's process for nothing, but actually it's a decision behind it that needs to be reevaluated constantly. So, and another example is WhatsApp. Happy example, where they actually thought about what we're going to build. We're going to build distributed systems that need to send messages. We want to ship faster. We need to make sure that the messages are delivered. They looked around, and lo and behold, Ericsson actually developed a language and a virtual machine, Ericsson language, Erlang, and Elixir built on top of it, that already solved this problem for them. So they could have went with some other way, use JavaScript on backend, use Java, C#, whatever, and reinvent distribution. But because they actually early enough identified what do we want from this system, they were able to tell, okay, it will be Erlang, and yeah, it's not the most performant language, but it solves bulk of our problem. And they use NIFs to do Go and recently Rust, if they're actually hitting performance bottleneck. But they don't need to pivot. They're very small team of engineers supporting massive infrastructure, just because they were conscious about what are we building, what is the pain point we're trying to address, how would behave 2 years from now, 5 years from now. What will if we have not 100,000 users, but a billion users, and there's not much to say here, because people thought about it and they continuously evolving. They're okay, Go doesn't give us same performance, same guarantee, so we will migrate to Rust before it became a problem, before solution became costly. So in a nutshell, architecture is a decision framework. As I said, before, it's a way, it's a science of making a decision. So not thinking on the last project I was successful by using Python, but actually think about what are we building today? When can I say that Python is not suitable? Because familiarity with the language, it's also a point. You cannot just discard it. We have 10 engineers familiar with Python, but we're gonna use I don't know Java for our next project. No, it's a valid point. It will be faster to ramp up with Python, but you have to define, okay, we take this as a decision point, as an argument towards Python, at which point this argument no longer holds, or when we need to at least reevaluate and say, okay, Python is still a good solution, or maybe you need to switch to Elixir, because Elixir have unique niche, and I think especially relevant here, because there are no replacements. So they're Erlang and Elixir in a distributed space, and today horizontal distribution is getting more and more prevalent. So solutions that run on a single server is rather an exception. But very few companies adopting Elixir and Erlang, because they don't have a decision framework on a higher level than engineers that say okay, we don't want to solve how Beam is built by ourselves. We need to take what's already on the market, because it gives us solution for 80% of what we're going to build. So do conscious decisions. And to try to bridge a gap is like usually communication language is diagrams. So when architect asked a question, he oftentimes produced a diagram. But by engineers, like myself included, like before I like turned into architecture, I thought like diagram is an architecture. It's an artifact. It's it's a decision. Like whatever information there is, it's in a diagram, and this whole piece was missing. So usually when you have like an architect, he is like supporting like enormous architecture document, and diagram is like a slice, it's a projection. For like an engineer, like you need a question like, what components should I have? It will be like a few blocks. And for network engineer, it will be like how it should be connected, like this. But then there are like certain rules. For example, like in Standard Chartered, we implemented a zero trust network. So like we start like with a dark network, nothing available from anywhere. And you need actually a network architecture document to enable like any kind of communication. But like it's all derived from the same architectural document, because it's like holistic view requires like both like network architecture, component architecture, data architecture, all like, but you don't need to present like this whole piece to any individual person. So like data architect, he doesn't care about like how you implement network security. He cares about like how you protect personally identifiable data. So okay, but for that we have different storages, and we clearly communicated to engineers that like, yeah, it's inconvenient, but you actually have to store this data like in this database. This slice of data you'll put like in, I don't know, like in the different type of database. For example, like transaction you put in a blockchain, and customer information you put in like this Postgre database, but but address and name and birthday you put in a separate database. Yeah, it's inconvenient, but actually there's like a good reason behind it, because this another database for PII information, it's encrypted and the regulator regularly like validated. So you don't want to put like a lot of data there, because scaling it is like extremely expensive. And the performance probably like not as good, because like it's encrypted on a file system level, it's encrypted on table level, and sometimes like on top of that, also on a column level, it might sometimes be a requirement. While you can have your transaction data that you just want to be immutable, but it doesn't require like nearly the same level of protection. So like if your transaction like ledger leaks outside, yeah, it's embarrassing, but it doesn't get you in as much trouble with regulator compared if your PII information leaks. And then if your customer preferences leaks, then like mostly people don't care, because customer's not identifiable. So like whatever, we need to store it cheaply. And we like, if we lose this data, also not a big deal. So like archival principles would be different. But imagine like from engineer perspective, you have to split your data like in 3 databases, like 3 connection strings, like why? And usually no one telling like to engineers like why. Yeah, so do you have reevaluation points for decision in your company? Do you like consciously thinking like when whatever we decided like not longer stands true, maybe like you need to think about it, and maybe it will save you from a lot of pain in the future? Yeah. So any questions, comments? Okay.
Microservices. Comment.
Microservices
will save us.
It deserves its own separate talk, but in a nutshell, like it's a bold statement, but almost no one doing microservices right. So in most cases, like what is presented as microservices, it's smeared around monolith. And it's easy to validate. So like if you, to make a change, you have to touch multiple microservices. It's not microservices anymore. And to make it work, you need to productionalize each of your microservices. Otherwise, they're not like building blocks. It's like imagine like you building a house, and when to make a change, you need to like pick out like random bricks and make properties, make them from different material, like kids. You cannot use the brick factory for this. So why you can use, for example, like MS SQL, like SQL, any SQL database, it's been productionalized. You have like strict standard, like SQL doesn't change it like on a whim. It have a performance property. So like a lot of things are known and stable about the databases. So same should apply to microservices if it's true microservices. It have like certain properties that are very hard to change. So good indication if you actually using microservices, whenever the question is like, oh, this microservice is not 100% like suitable for our task, you throw it away and put a new one in place. And you have like some transition plans that like, okay, like we're gonna switch to a new one, and the old one will be phased out when it's not receiving messages anymore. But like, if you say like, oh, I'll just like go modify it, I'll add, I know, like a field to like a JSON, it's not really a microservice. It's just like you decided to use HTTP as a communication within monoliths.
So this is based on our previous conversation, but please comment. So on our previous conversation, we talked about crystal doghouses.
Mm-hmm.
The crystal doghouses could be held together with something else, and so in some ways where you have like
mm-hmm.
a language for building like your crystal doghouses, but then you have a different language for connecting all your crystal doghouses where it's like
mm-hmm.
okay.
Okay, a little bit of context. So like, what is crystal doghouses like? What does it mean? So there is an argument, and it actually stems from over-architecture. So you can be overly strict, you can be over-architect. In my previous example, like you have a startup and you're using ADA. Everything's solid. You have TRM like proved like for everything you build in it. But you're a startup. You need to pivot left and right. Like your requirements change. You like discover new things, and ADA gives you like a crystal palace. It's very hard. It's very sturdy. You can like pick it up and like move it to another like place compared to like end pile. But if you actually need to make a change, it's very expensive. So what you can do is like you use like whatever tools give you like flexibility and speed. And when you see, okay, this is actually solidified. I want it behave certain way. I identified this properties for a part of a system. For example, it handling PII. It should have like certain properties, like performance properties, how it's encrypt data, what information can be received, and how it can be retrieved. For example, like for retrieval, like very big part, like what kind of authorization required for this. Okay, this would be like it's a very small piece of my system. That's where the crystal doghouse came in, but it's like very solid. It's immovable, and yeah. To your question now. So yeah, making Crystal Palace is expensive and rarely needed. So using one language for like entire system, it's actually rarely viable. So you want like small pieces, a lot of like crystal doghouses that are solid, that's a requirement. Like you have like regulatory requirements, like law says like you can do this, you cannot do this. It's critical for reputation of your systems that like you never give like wrong advice. So like if you're doing like robo-advisory, like for investment, you make sure that like you either give good advice, neutral advice, or no advice at all. So like you build the controls around it that say, okay, like if I'm not happy with the quality of my advice, it doesn't give them. And you like codify it as like your crystal doghouse, or like this is the rule, unbreakable. But how you communicate between crystal houses, it actually doesn't have to be like strict, because you still need the flexibility. You want like new products on the market. You want to ship like fast. Maybe you need like 2 doghouses. Maybe you want to have a deployment like in Bahrain and in Mexico, because they have like different regulations. But the way these systems are glued, you don't want a doghouse that covers both Bahrain and Mexico. So like no value in this, and therefore you need to use 2 different kinds of language, 2 different kinds of infrastructure. One to put something immovable, and then something like to glue them together and like modify this connection whenever it's useful. And it's like back to like this point, like what WhatsApp did right. So like yeah, we have a Rust because performance and actually type safety. So it's way harder to modify Rust parts, but that means once it's been implemented, it's actually harder to make to introduce errors there. If your type system always like watching over you, making really nearly change. Like you cannot do monkey patching, for example, in Rust. But like in between, like when you like sending messages around, it can change format. Like you can introduce new values, like when you change message around. And Elixir, like it's a great glue. It delivers your messages across the globe fast and reliable. And if part of your system change, you can still glue them together without like having like a major overhaul, because like you have this like something flexible in between. But yeah. So like think about like what is like crystal and like fixed in place, and what is not, and like not mix them together, and like you have like much easier life delivering like almost any application. I think this is like architectural advice that universally applicable. Usually architects you say like I don't know, it depends, because they're like they know architectures that like fits like everyone, otherwise they like wouldn't be a talk about architecture. We just have like, okay, you have to do microservices this way, and you solved. We're not there yet, and therefore like good architect should not give like architecture advice actually, unless he's embedded in the project. Yeah, you wanted to ask something as well.
Yeah, I was going to ask if you have any advice for introducing a culture of change, decision, reevaluation in an organization.
Asking questions. So like whenever you're presented like with a answer, with a solution, like our architecture is like this, like ask like why is it like this? When it becomes fair, like with enough questions, you might get an answer. Like it happens in Standard Chartered. So like we like are keeping tracks of like reasons for each decision. So you can always backtrack to like where it came from. But like as an engineer, you ask questions. Ideally, it should come like from like top management saying, okay, like we have to have like a control over the cost now and in the future. And it's like their headache. So like from bottom up, it's sadly that doesn't work very well, but like asking question and say like what justifies this decision, like architects should be able to answer. If he unable to answer, then it's a question about like, should you even like follow the, is it like real constraint if it's not explained like where it came from? And again, like if it's scientific, it should be falsifiable. It should always come, it's true until this condition is met, like until like we grew past like 20 engineers. Any more questions?
One more, because I didn't understand this until we actually had our conversation previously for the setup of this talk, is that an architect is in a sense like a constraint solver, that you're saying, you've got this constraint, you've got this constraint, you've got this constraint, what's the path that actually like ties them all together? And in the case of like something like Dropbox, where they kind of painted themselves into a corner, and then the constraints were very tight, where they basically only had like a handful of kind of
options,
jail options.
Yeah.
Whereas with WhatsApp, because they chose early enough, then it's like, well,
and they keep choosing.
we can kind of do whatever we wanted here, but at this point in time, like, what's the best path? Yeah, I just didn't understand previously that the architecture aspect is like effectively constraint solving and then choosing an optimal path when given. Is that a reasonable way to understand it?
No, not really. So we actually like again talk about it. So architect, especially enterprise architect, he is not a domain expert of like most areas of the say the enterprise. So you have a team that working like on payments, a team working on like a network, and you cannot imagine like if you can have like one person who can like grasp all the fields, you just like need handful of people like this, and like you're golden. They like just like talk among themselves, because like part of like architecture work is like communication. But if you like have like 5 super smart guys that like can do everything, they have very little communications, they can achieve like great thing. So architect is not looking for optimal path. Architect codifies it. So you as an expert in your field came to me, say like, this is the constraints. So like I know like organizational constraints that like we, for example, like not gonna adopt Haskell, because it will be only one project that using Haskell, and we know that okay, it would require like entire infrastructure around it. So like we need to run Haskell, we need to make sure that like it's sustainable, we're not like subject to a bus problem. So architect codifies it. So you as an expert in your field came to me, say like, this is the constraints. So like I know like organizational constraints that like we, for example, like not gonna adopt Haskell, because it will be only one project that using Haskell, and we know that okay, it would require like entire infrastructure around it. So like we need to make sure that like it's sustainable, we're not like subject to a bus problem. So architect's not going to give you optimal path. But like when you came to architect with a path, it have to make sure that it documented why we chose this path and what is the failure point of this path by expert words. So you as an expert come to me, says this is a path. As an architect, I have to ask you like why it is a path and until what point it is not a path. And it's in a sense not very smart job because I'm just like put it like in my architecture document that there's these arguments. I might not be able myself even like to evaluate these arguments because I'm not a domain expert, but at least both being answered and recorded. And if you like leave a company and have another guy who's like domain expert here, and he like came to like architect us like why you chose like to do it this way. As an architect, it should be able, or like another architect should be, oh, like in our architecture document, this is a decision, this is argument 4, and when it doesn't hold true anymore, are you saying it's not hold true anymore, or you disagree with the 4 argument? And then you record, okay, like this decision been rejected based on our new domain expert, and this is arguments that like what was before, what was the argument for against, this is what's now, what was the driving point to make a change. And again, like architect probably like will take into account like what is the budget to make a change, and we'll put it as a like non-technical constraint there as well. And oftentimes architect says like, no, it's a great solution, but it's not financially viable. We can rewrite everything like in Elixir, and it's a better choice, but we already so deep into Python that like like MyPy now it's more viable. We have to keep it like maybe in the back burner, like start the teams that like start writing it like an Elixir, so it won't be like oh like we stop the job, like close the Dropbox and start rewriting it, and in a year we'll try to crawl back into a market. So Elixir architect might say like no, but like he's not the source of optimal path. He's just there to make sure that decisions are made properly, that it's like you're following your like framework to make decision. Answers your question?
I think so.
You
feel
think?
like it's like halfway between an accountant and a lawyer.
Yeah, closer to accountant. Accountant who manages like not money,
Yeah.
but decision, like taking into account like
Yes.
why is it there?
Yes.
Yeah.
Advisory accounting.
Yeah.
Yeah, and this might be also like a misconception that like architect is like as technical as an engineer role. It's less. You like as an architect, architect needs an understanding. So like it's not a total bullshit like what our engineer uses like a justification for a solution, but there's no chance that like enterprise architect will be able like to grasp like everything engineer like present to them. Like it's like not practically possible for humans at least. Maybe AI architects will be there and say like, oh, hey, it will keep it cohesive. Yeah. Any more questions? Okay, thank you.